Hello everyone. In this video, we are going to introduce a useful mathematical tool that is called logarithm, which will help us in performing some calculations related to either very large number or very small number. So let us begin this discussion by understanding the definition of logarithm. We can express a given number in terms of a base and an exponents. For example, the number 64 can be expressed as 8 to the power 2, where the number 8 is the base for this expression and this number 2 is representing the exponent. It means that 8 multiplied by itself 2 times will give us 64. Okay, so now we will ask a reverse question, that is 8 to the power which number will give us 64. It means how many times should we multiply 8 by itself to get us 64. Okay, and the same question can be repeated in terms of logarithm as logarithm of 64 to the base 8 is equal to which number? Okay, so please try to relate these two expressions, expression 1 and expression 2. In the expression 1, we are asking 8 to the power which number is equal to 64, and we are repeating the same question again. Logarithm of 64 to the base 8 is equal to which number? So here we are representing the unknown number by the letter n. So logarithm of 64 to the base 8 will be equal to n, and which is in this case is numerically equal to 2. Now 64 can also be expressed as 4 to the power 3. Here the base is 4 and the exponent is 3. Now we will repeat the same exercise with the base, with a different base here, that is 4. 4 to the power which number is equal to 64, right? And in terms of logarithm, we can ask same question again. Logarithm of 64 to the base 4 is equal to which number, which is here numerically equal to 3. So please note that we are taking the logarithm of same number, that is 64 in the both cases, but by changing the base we are getting different values which we also expect, right? So changing base for same number in logarithm can give us a different result which is accurate in their respective cases. So to put a general definition of logarithm, we can say that if we can express any number p in terms of a base and an exponent m raised to the power n, then this exponent in the expression can be expressed in terms of logarithm as log of p to the base m. Okay, so once we have understood the definition of logarithm, let us see how logarithm helps us in performing calculations. For example, let us say we have a small number in one of our expressions, that is 0.0001, which can be expressed in terms of a base, that is 10 to the power minus 4, which is the exponent in this case. So we will express the exponent here minus 4 as logarithm of 0.0001 to the base 10. So how it helps? Here in logarithmic scale we are inputting a very small decimal value, that is 0.0001. Okay, and after conversion we are getting quite a decent integer in this case, that is -4. Now performing calculations with -4 is going to be a lot more easier than performing calculations with this decimal. Okay, so similarly, let us take another example. Let us suppose we have a number 0.00125, which can be expressed as 125 times 10 to the power -5. Now here we would like to ask a question. We are specifically mentioning the base for the expression as 10, and we would like to know that how many times should we multiply 10 by itself to get 0.00125. That is 10 raised to the power n is equal to 0.00125. Then what is the value of this n? In terms of logarithm, this can be expressed as n to be equal to logarithm of 0.00125 to the base 10. Okay, so we are trying to calculate the value of an unknown quantity, that is n in this case, and now we can see that we will need some tools in order to operate within this logarithm scale in order to get the value of n. So now onwards we will be focusing on the rules that helps us to perform calculations in logarithmic scale. Let us now get familiar with the rules for calculations in logarithmic scale, and we will keep the definition of logarithm for our reference in order to understand these rules. So the first rule says that logarithm of any number p to the base p will result in the value 1. So let us take an example in order to understand what this rule says. For example, we can express the number 5 as 5 raised to the power 1. Okay, now this 1 can be expressed in logarithmic scale as logarithm of 5 to the base 5. So any number raised to the power 1 will always result in the same number, and that is why this rule follows this result, that is logarithm of any number to the base itself will always give us the value 1. Okay, so this is a very useful result which will help us in minimizing or performing calculations much easier. Let us see the next rule. Logarithm of 1 to any base m will always give us 0. So for example, we can express 1 as 5 raised to the power 0, or any other number we can replace 5 with any other number raised to the power 0 will always give us 1, and hence we will express 0 as logarithm of 1 to the base 5 in this case. So if we generalize this numerical value with any alphabet, that is m in this case, any variable m, it will result in the second rule that we have just noted down, that is logarithm of 1 to the base, any base, is always equal to 0. So these two rules are a kind of outcomes of rules of base and exponents, and both these rules will help us to perform calculations in simplifying them a number of times. Now let us have a look at the third rule of logarithm, which says logarithm of p to the base m, where p can be expressed as a raised to the power b. Okay, so we can simplify this expression by taking logarithm of a, which is the base within the bracket within the logarithm scale, to the base m, and multiplying this logarithmic expression by b, which is the exponent within the logarithmic scale. So let us take an example in order to understand this rule. Here we would like to calculate logarithm of 125 to the base 5. Now 125 can be expressed as 5 raised to the power 3. Okay, and now as per the rule number 3, the exponent here 3 can be multiplied to logarithm of 5 to the base 5. And as per the rule number 1, this expression here, logarithm of 5 to the base 5, is equal to 1, and hence we will get the final result for this expression as 3. Okay, so logarithm of any number p to the base m, where p can be expressed as a raised to the power b, can be simplified by taking logarithm of a to the base m and multiplying this logarithmic value with b. Now a direct conclusion of this rule can be noted down here. Logarithm of any number 1 by a, okay, it can be expressed as a raised to the power minus 1. 1 by a can be expressed as a raised to the power minus 1, and according to the third rule that we studied, this minus 1 can be multiplied to the entire logarithmic scale, and hence it will give the result as negative of logarithm of a to the base m. So let us move ahead and see some other rules for performing calculations. We will keep the first 3 rules that we have learned as a reference. Now in the rule number 3, we have expressed p as a raised to the power b. Here we are performing calculations logarithm of p to the base m, where p can be expressed as multiple of two numbers, that is a times b. P here is broken as a times b. Then this entire expression logarithm of a times b to the base m can be simplified by taking separate logarithm of each number within the bracket and then adding both logarithm expressions. That is, we will simplify logarithm of a times b to the base m as logarithm of a to the base m plus logarithm of b to the base m. Okay, so for example, let us say we have to calculate the logarithm of 375 to the base 5. Then this 375 can be expressed as 125 times 3. Now we have to simplify this entire expression within the logarithm, and we will simplify this by taking logarithm of 125 to the base 5 and logarithm of 3 to the base 5 and then adding the result, and it will give us logarithm of 125 to the base 5 plus logarithm of 3 to the base 5. Okay, so this is how we will simplify any calculations involving logarithm where the given number can be broken down as multiples of two or more numbers. Okay, so this can also be generalized for more numbers in the same manner. Similarly, if we have to perform calculations involving logarithm of p to the base m, where P can be expressed as A upon B. So we will be operating on logarithm of A upon B to the base M. Okay, and this expression can be simplified as logarithm of A to the base M minus logarithm of B to the base M. For example, if we have to perform calculation logarithm of 125 to the base 5, then this 125 can be expressed as 625 upon 5. So logarithm of 625 upon 5 to the base 5 can be simplified as logarithm of 625 to the base 5 minus logarithm of 5 to the base 5. Okay. Let us summarize all the results that we have learned so far. In rule number 1, we learned that logarithm of any number to the base itself is equal to 1. Following this, we learned that logarithm of 1 to the base any number is equal to 0. Rule number 3 says if we can express a number p as a raised to the power b, then this expression can be simplified as b times logarithm of a to the base m. Similarly, if p can be expressed as a times b, then this entire expression of logarithm can be simplified as logarithm of e to the base m plus logarithm of b to the base m. And finally, if p can be expressed as a upon b, then the logarithmic expression can be simplified as logarithm of a to the base m minus logarithm of b to the base m. I hope the fundamental concepts of logarithmic calculations are clear to you. Thank you so much for watching. In the next video, we will be applying these rules that we have learned so far in calculation of pH of acids and bases. Thank you once again.